Hi, this is Michael Maddie of MCM Design. MCM are my initials. I'm the guy that built two modified for high-res Astrocades. The first high-res Astrocade rests on a Viper 1 cabinet and includes interfacing to connect up to 5 remote devices. This Astrocade utilizes the standard 32 chips of dynamic screen RAM. The second high-res Astrocade shown on the left is just a wire-wrapped prototype, but utilizes only 4 static screen RAM chips. The add-under board is powered by a single 5-volt supply. These two Astrocades will be detailed in an upcoming 4-part video series which will show the Astrocades running in low or high res. The Astrocades will also be disassembled so you can take a good look at their hardware. This is my first video for my new YouTube channel, MCMs Astrocades. I thought I would start out by touring some of my projects along with other related stuff. I hope you enjoy this intro video. So let's see what I've been up to. This is my upgraded Belchik HR breadboard. It still utilizes a 32 KB EEPROM with 4 diagnostic programs and a dual 7-segment display with a custom decoder. However, I added a remote Z80 CPU and a 74LS367 tri-state hex buffer. A small 5-volt power supply was also added to run long programs. There is still a 9-volt battery option to run the 20-second Belchik program. This upgraded Belchik HR scheme will be detailed in an upcoming video series. Here are some diagnostic tools that I use to troubleshoot an Astrocade motherboard. I have an old CSC frequency counter, an analog multi-tester which I bought at True Value Hardware, a TTL CMOS logic probe by K&H Products, model LP-3500, and finally a King's 16-channel LA1010 logic analyzer. Thanks to Ken Lill and Adam Triumphal for pointing to me this particular logic analyzer. Thanks, guys. I modified 3 Astrocade cassette cartridges. The first one supports EEPROMs and EEPROMs using a reroute socket. It is also multi-carded for a 32 KB chip providing 4 8 KB programs. The downside of this setup is the risk of installing the chip backwards. The second cartridge contains a 28-pin 8 KB EEPROM programmed with the Belchik HR program. The third cartridge is similar to the first and has a more appealing look utilizing a 28-pin ZIF socket. I also programmed a bunch of EEPROMs. One is programmed with a low-res to high-res conversion of the Astrocade UPI and onboard subroutines. I also have an 8K EEPROM, courtesy of Adam Triumphal, who programmed this EEPROM with my high-res static screen RAM multi-pager test demo. Thanks, Adam, for this gift. Another EEPROM is programmed with the high-res MMM which is an upgraded version of Bitfiddler's machine language monitor. And finally, 2 EEPROMs were programmed with test routines when I was developing my modified for high-res static screen RAM Astrocade. I wanted to show the 3 PC board add-under supports I bought on eBay for my final modified high-res Astrocade that I'm planning to build. There's really not that much to the supports, which includes some mounting brackets. I will have to create additional wood supports to make my 3 PC board horizontal rack idea work. I will cut down a 8.5 by 17 inch pre-punched vector board in half, giving me a precise 8.5 inch wide board. The pattern transfer board may be longer than 8.5 inches. All 3 boards will be wire wrapped. You can also see my 7 by 8 inch high-res static screen RAM breadboard with 1 small piece missing. These breadboard pieces were trimmed down using a table saw to keep wiring as short as possible. The 4 static RAM chips and 4 74LS166 video scan chips will be elevated using wire wrap sockets so wiring can be routed under the chips instead of around them. This breadboard will also be used for experimenting with the Perkins high-res interfacing scheme, only I will be using static RAM instead of dynamic RAM. You can also see I was experimenting with the pattern transfer chip MC14516B, which is used as an up or down counter. There's 12 of these chips on the pattern transfer board. I used a 555 timer to generate a single pulse per second, slow enough to observe 4 LEDs counting up or down in binary. One of my projects was to try to fix 6 Astrocade motherboards that Alan Schweitzer shipped to me. I did manage to fix all 6 motherboards. The story is archived on the Bally Alley website. In appreciation, Alan let me keep this board, which is labeled as Alan BD1. This board was nearly socketed 100% by Alan. Only 3 chips have no sockets. I can use this test board to test a suspected chip that I have removed when troubleshooting another motherboard. As you can see, I like to label the chips to match the Bally schematic and motherboard layout shown in the Bally PA-1 service manual, which is archived on the Bally Alley website. Labeling the chips speeds up locating specific pins when probing or attaching diagnostic tools. The back of the motherboard has a 50-pin connector where I can plug in my Belchik HR diagnostic board. This diagnostic board is a must-have to help isolate motherboard issues. I wanted to show what I use when it comes to using number 24 hookup or number 30 wrapping wire. The 6-pack hookup wire kit by Consolidated Electronic Wire and Cable is the way to go. You'll save money buying the kit and get multiple colors. The solid core wire is tinned and won't tarnish after long exposure to air. Using the more expensive wire stripper makes it easy to strip off the wire insulation. This insulation also stands up very well to a 25-watt soldering iron. The 6-pack kit by Electronic Express is the way to go for number 30 wrapping wire. It uses the Kynar insulation, which surprisingly stands up very well to a 25-watt soldering iron. This is what I use for the modified for high-res motherboard when I hardwire motherboard signal lines to the ribbon cable wire wrap socket, which is mounted on the bottom of the motherboard. Wrapping tools are high priced. You typically get the number 30 wire stripper here on the left, which can be stored inside the barrel of the wrapping tool. I'll use a solder probe or small flat-edge screwdriver to hold the number 30 wire in place while I wrap wire around an IC socket wrapping post or reposition number 30 wrapping wire that's already on a wrapped board. This is my motherboard power transformer substitution board. It utilizes two Jenko power transformers. A while ago, I heard one of these transformers was discontinued. You can still substitute other transformers like this one on the right. This is an old Radio Shack power transformer. Secondary is rated 6.3 volts, 1.2 amps. Primary is rated 120 volts, 60 hertz. The power transformer substitution is fused on the primary side, shown here, and also includes a breadboard on the secondary side to test suspicious motherboard power supply components that have been desoldered from the motherboard. The power supply board can be used if the 100 microfarad C10 electrolytic capacitor on the motherboard is rated at least 35 volts. This cap is located next to the custom address and input-output chips. Documentation, including photos for this substitution scheme, is archived on the Bally Alley website. There is also a custom 120 volt AC socket along with a primary fuse, shown here, to plug in the standard black power transformer. Plug it in just like this. Here's the secondary connection right here. This is my Astrocade that is modified to run in low or high resolution, requiring only 4 screen static RAM chips. You can also see an experimental breadboard mounted on top of the RF modulator. This board is wired with a 2-transistor composite video driver scheme used in the Datamax UV-1R computer, and also includes an audio driver using the 8-pin LM386 chip. I plan to experiment with the Texas Instruments THS 7314 driver chip to compare the resulting TV display with the present video driver scheme on the board now. I am also going to take a look at using 3.5mm jacks instead of RCA jacks. These jacks would likely end up on the back of my prototype board. I'm now going to flip this Astrocade over so you can see the add under board. This is the add under board for my modified for high-res Astrocade with screen static RAM. Here's a quick tour. 4 screen static RAM chips, 4 high-res video scan chips, 4 video data line drivers, receivers, low high-res timing circuitry in this area, the multi-pager decoding in this area, the user RAM-ROM decoding, a few chips here, 2 32 KB user static RAM chips here and here, and finally a provision for an 8 KB high-res ROM EEPROM right here. This is my last video clip. I already mentioned 2 upcoming video series projects. What you're looking at are 5 piles of documentation for other projects I'd like to work on. The first pile on the very left is documentation for an ongoing tutorial project called an In-Depth Look At series, which is being written for machine language and assembly language programmers looking for more info related to the Astrocade BIOS, in particular its UPI and user subroutines. 7 lessons are archived on the Bally Alley website. Lesson 8 is partially written. The second small pile is some quickie projects. The third pile is documentation for a project which will detail all MCM Design low and high-res programs for posting on my YouTube channel. The next pile indicates my desire to write a troubleshooting procedure to speed up a diagnosis for a motherboard powering on with a black screen. The MCM Design Bellcheck HR diagnostic package, along with other diagnostic tools, will be required to isolate a motherboard failure. The last pile on the very right is documentation for my most challenging project to build my final modified for high-res Astrocade with a 3-board add-under.